Clear heat shrink tubing for underwater splices typically does not contain embedded sealant. It achieves a watertight seal through tight shrinkage around the wires when heated. Durable waterproof material like polyethylene or polyolefin, and sometimes a thin layer of waterproof adhesive on the inside surface that melts and bonds to the wires. Check the product specifications to determine if there's an adhesive layer, as it is not always visible. Additional sealant may be necessary in submersible applications with high water pressure or prolonged submersion. Splices made with dissimilar metals like copper and aluminum where corrosion could occur, and splices subject to extreme temperature fluctuations or vibration. If you need extra sealant, purchase heat shrink tubing sealants that are injected into the tubing before heating, containing grease, gel, or epoxy resin for added water protection. For underwater splices, use heat shrink tubing specifically labeled for that purpose and carefully follow the manufacturer's instructions. If unsure about sealant, contact the manufacturer. Waterproofing electrical splices involves several key factors ensuring a reliable and safe connection, especially in demanding environments like underwater well pump applications. The primary defense against water intrusion is the heat shrink tubing itself. High-quality tubing is made from materials like polyethylene or polyolefin, known for their excellent resistance to moisture and chemicals. This material acts as a barrier, preventing water from reaching the conductive parts of the splice. The effectiveness of this barrier depends on the integrity of the tubing and its proper application. When heated, the tubing shrinks to a specified diameter, tightly gripping the underlying wires. This tight fit is crucial for creating a watertight seal. The degree of shrinkage, often expressed as a ratio, such as 21 or 31, indicates how much the tubing will shrink from its original diameter. A higher shrinkage ratio is generally better, as it allows the tubing to conform more closely to the shape of the wires, even if they are slightly irregular. The amount of heat applied during the shrinking process is also vital. Too little heat and the tubing will not shrink sufficiently, leaving gaps for water to enter. Too much heat can damage the tubing, causing it to crack or lose its elasticity. A heat gun is the preferred tool for shrinking the tubing, as it provides a controlled and even heat source. A lighter or torch can be used, but it requires more skill to avoid overheating the tubing. Some heat shrink tubing products include an adhesive lining on the inner surface. When heated, this adhesive melts and flows into the gaps between the wires, creating a secondary barrier against water intrusion. The adhesive also helps to bond the tubing to the wires, providing additional mechanical strength to the splice. The type of adhesive used is important. It should be waterproof, electrically non-conductive, and compatible with the wire insulation. Some adhesives are also designed to resist chemicals, oils, and other contaminants that may be present in the environment. When using adhesive-lined heat shrink tubing, it is important to apply enough heat to melt the adhesive completely. This will ensure that the adhesive flows properly and creates a solid bond. You should see a small amount of adhesive oozing out from the ends of the tubing when it is fully heated. In situations where the splice will be subjected to high water pressure or prolonged submersion, additional sealant may be necessary. This is particularly important for submersible well pumps, which are constantly immersed in water. Several types of sealants can be used, including epoxy resins, silicone greases, and petroleum-based gels. Epoxy resins provide a very strong and durable seal, but they can be difficult to apply and remove. Silicone greases are easier to apply and remove, but they may not provide as strong of a seal. Petroleum-based gels are similar to silicone greases, but they may be more resistant to certain chemicals. The choice of sealant will depend on the specific application and the materials being spliced. When applying sealant, it is important to fill all of the gaps and voids in the splice. This will prevent water from penetrating and causing corrosion. The sealant should also be compatible with the wire insulation and the heat shrink tubing. Some sealants can damage or degrade certain types of insulation or tubing. Splices made with dissimilar metals such as copper and aluminum are particularly vulnerable to corrosion. This is because the metals have different electrical potentials, and when they are in contact in the presence of moisture, an electrolytic reaction occurs. This reaction causes one of the metals to corrode, weakening the splice and eventually leading to failure. To prevent corrosion in dissimilar metal splices, it is important to use a sealant that contains a corrosion inhibitor. Corrosion inhibitors are chemicals that react with the metals to form a protective layer, preventing the electrolytic reaction from occurring. Splices that are subject to extreme temperature fluctuations or vibration are also at risk of failure. Temperature fluctuations can cause the splice to expand and contract, which can loosen the connections and allow water to enter. Vibration can cause the wires to rub against each other, which can wear away the insulation and expose the bare conductors to moisture. To protect splices from temperature fluctuations and vibration, it is important to use a heat shrink tubing that is designed to withstand these conditions. Some heat shrink tubings are made from materials that are more flexible and resistant to cracking than others. It is also important to secure the splice properly to prevent it from moving or vibrating. Proper wire preparation is essential for creating a waterproof splice. The wires should be stripped carefully to avoid nicking or damaging the conductors. Nicks and scratches can create points of weakness where corrosion can begin. The stripped ends of the wires should be clean and free of any dirt, grease, or corrosion. If the wires are corroded, they should be cleaned with a wire brush or a chemical cleaner before splicing. The wires should be twisted together tightly to ensure a good electrical connection. A loose connection can generate heat, which can damage the insulation and accelerate corrosion. The splice should be smooth and free of any sharp edges or points. Sharp edges can puncture the heat shrink tubing, allowing water to enter. The length of the splice should be appropriate for the size of the wires. A splice that is too short may not provide a strong enough connection. A splice that is too long may be difficult to fit inside the heat shrink tubing. The National Electrical Code, or NEC, provides guidelines for making electrical splices. Section 110.14 E covers splicing of conductors. It states that splices shall be made with splicing devices identified for the use. All splices shall be covered with an insulation equivalent to the insulation of the conductors or with a listed insulating device identified for the purpose. Section 300.15 covers boxes, conduit bodies, or fittings, where required. A box shall be installed at each outlet and switch point for concealed knob and tube wiring. At each splice point of concealed knob and tube wiring, the conductors shall be enclosed in a box. Section 314 covers outlet, device, pull and junction boxes, conduit bodies, fittings, and handhole enclosures. These sections cover the installation and use of boxes and enclosures for electrical connections. Section 430.22 covers single motor. Conductors supplying a single motor used in a continuous duty application must have an ampacity of not less than 125% of the motor's full load current rating. This section covers the sizing of conductors for motors, including well pump motors. The depth of a well can significantly impact the electrical requirements of the pump. Deeper wells require more powerful pumps to lift the water to the surface. More powerful pumps draw more current, which requires larger conductors and appropriately sized circuit breakers. The voltage drop in the conductors can also be a concern in deeper wells. Voltage drop occurs when the voltage at the pump is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can reduce the pump's performance and shorten its lifespan. To minimize voltage drop, it is important to use conductors that are large enough to carry the current without excessive resistance. The length of the wire run is also a factor in voltage drop. Longer wire runs will have more voltage drop than shorter wire runs. The type of wire used for the splice can also affect its waterproofness. Solid wire is generally more resistant to water intrusion than stranded wire, as there are fewer gaps for water to penetrate. However, stranded wire is more flexible and easier to work with, especially in tight spaces. If stranded wire is used, it is important to twist the strands tightly together to minimize the gaps. The insulation on the wire should be compatible with the water and other substances that may be present in the environment. Some types of insulation can degrade or crack when exposed to water, which can allow water to enter the splice. The size of the wire should be appropriate for the current that it will be carrying. Using undersized wire can cause the wire to overheat, which can damage the insulation and create a fire hazard. The tools used to make the splice can also affect its waterproofness. Wire strippers should be used to remove the insulation from the wires without nicking or damaging the conductors. Crimping tools should be used to crimp the connectors onto the wires. A good crimping tool will create a tight and secure connection that will not loosen over time. Heat guns should be used to shrink the heat shrink tubing. A heat gun will provide a controlled and even heat source that will shrink the tubing evenly without damaging it. Multimeters can be used to test the continuity of the splice. A multimeter will measure the resistance of the splice, which can indicate whether there is a good electrical connection. The installation environment can also affect the waterproofness of the splice. Splices that are installed in wet or humid environments are more likely to corrode than splices that are installed in dry environments. Splices that are installed in areas where they are exposed to chemicals or other contaminants are also more likely to corrode. To protect splices from the environment, it is important to use a heat shrink tubing that is resistant to water, chemicals, and other contaminants. It is also important to seal the splice properly to prevent water and other contaminants from entering. Regular inspection and maintenance can help to ensure that splices remain waterproof over time. Splices should be inspected regularly for signs of corrosion, damage, or wear. If any problems are found, the splice should be repaired or replaced immediately. The heat shrink tubing should also be inspected for cracks or tears. If any cracks or tears are found, the tubing should be replaced. The connections should be checked to make sure that they are still tight and secure. If any connections are loose, they should be tightened. The location of the splice can also affect its waterproofness. Splices that are located below the water line are more likely to corrode than splices that are located above the water line. Splices that are located in areas where they are exposed to direct sunlight are also more likely to corrode. To protect splices from the elements, it is important to locate them in a protected area whenever possible. If the splice must be located in an exposed area, it should be protected with a waterproof enclosure. The type of pump being used can also play a role in the electrical connections required. Submersible pumps, as previously mentioned, require special considerations due to their constant immersion. Jet pumps, on the other hand, are typically located above ground and may have different wiring requirements. Centrifugal pumps, another common type, may also have specific electrical needs depending on their size and application. Understanding the specific requirements of the pump being used is crucial for making safe and reliable electrical connections. Grounding is a critical aspect of electrical safety, especially in wet environments. Proper grounding helps to protect against electrical shock and prevent damage to equipment. The grounding conductor should be connected to the pump motor frame and to the electrical panel. The size of the grounding conductor should be appropriate for the size of the circuit conductors per NEC Table 250.122. Ground fault circuit interrupters, known as GFCIs, are highly recommended for circuits supplying well pumps, especially those located in damp or wet areas. GFCIs are designed to detect even small amounts of current leakage to ground and quickly interrupt the circuit, preventing electrical shock. When working with electricity, always prioritize safety. Energize the circuit before making any connections. Wear appropriate personal protective equipment such as gloves and safety glasses. Follow all applicable electrical codes and regulations. If you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous, and it is always best to err on the side of caution. Always double-check your work to ensure that all connections are tight and secure. A loose connection can cause overheating and create a fire hazard. Properly label all wires and connections to avoid confusion in the future. Use a permanent marker to label the wires with their function. Keep a record of the electrical work that you have done. This record should include the date of the work, the type of work done, and any materials used. This record can be helpful for future maintenance and repairs. Consider the long-term maintenance of the electrical connections. Connections should be easily accessible for inspection and repair. Avoid burying connections underground or concealing them behind walls. Use materials that are durable and resistant to corrosion. Choose heat shrink tubing and sealants that are designed to last for many years. Perform regular inspections to identify and address any potential problems before they become serious. Selecting the correct components for the well pump system requires consulting the manufacturer's specifications. Follow the pump's installation manual. The manual includes information on the recommended wire size, circuit breaker size, and other electrical requirements. Deviating from the manufacturer's recommendations can void the warranty and create a safety hazard. The local electrical codes might have more restrictive requirements than the manufacturer's recommendations. Always comply with the most stringent requirements to ensure safety and compliance. When dealing with well pumps, remember that water and electricity are a dangerous combination. Take all necessary precautions to prevent electrical shock. Always to energize the circuit before working on any electrical components. Use GFCIs to protect against ground faults. Ensure that all connections are properly grounded. By following these guidelines, you can create waterproof and safe electrical connections for your well pump system.